Hello student, I hope you all are doing well. So today we are going to study further few more application of circular motion. But before going to that, we will take a short review what we have studied in last lecture because it is important. The further application also depend upon the few basic things. If that will be not clear, it not going to work. So the thing is, up to this or for further few derivations, we are considering all the motion in inertial frame of reference. So that's why your centrifugal force is balanced one. So what we studied first of all, that horizontal curve road and banked curve road, and the two conditions whether velocity is maximum or minimum. Okay, so let's take a short revision. Keep one thing always in mind. If forces are acting perpendicularly, so you don't need to work much more for that. But if forces are acting along theta, so your trigonometric functions will going to be work. There is sine theta, cos theta and tan theta, and we have to find the way how to resolve that, which we have studied in 11th standard in second chapter vector. While studying in this chapter, there are only main two tasks. What are the tasks? Your first task is to find weight balancing forces. Second task, centripetal force providing forces. So these two tasks every time you are going to perform, whether that will be for horizontal curve road, bank curve road, conical pendulum, or pendulum in a vertical motion. So the main thing is you are always going to find weight balancing forces and centripetal force providing forces. Okay, so what we did in first example, we studied about vehicle along curved surface. After getting this, you will understood that yesterday in last lecture we spent literally 10 to 15 minutes, and now you will within 2-3 minutes you will get to know that thing. So on horizontal curved surface we consider this kind of object. Here object is nothing but vehicle. So your first task is to find all the forces acting on the object. So here mg will going to act vertically downward. This point will be cg. What is that? Cg means center of gravity. After that, according to Newton's third law, if there is action, there will be equal and opposite reaction. So here reaction will be done by surface. The surface exerts force on the vehicle or object, and that force represented by normal. Okay, so this is what your vertical forces. Then after that, this object is performing circular motion. So that's why this object will going to perform circular motion, and that circular motion provided by frictional force. So frictional force between tire and road. Okay, so we have done with this. We have do all the forces acting on the body. So what is your first task? Weight balancing forces. So here is your weight. So balancing forcing is what? Normal. What does that mean? This will be what your vertical force. So vertical forces will give you information about weight. So vertical force, most of time our weight is nothing but vertically downward. That's why most of times your forces vertical will be given by that balancing weight. So here mg will be in this side and n will be on this side. So you will get n is equals to mg. So call it as equation number 1. Then after that we have done with all the forces which is acting vertically downward, vertically upward. Now we have done with vertical. Now we are going to consider horizontal. So horizontal, who is giving horizontal? Frictional force is giving horizontal, but what? Centripetal force. So horizontal force will give you information about centripetal force in this case. Okay, so horizontal forces are which forces? Now here you are going to neglect this part, so you will find that only frictional forces acting horizontally, correct? So only frictional force is acting horizontally, and what it is giving you? Centripetal force, which is nothing but mv square by r, or you may write mr omega square. So this will be your equation number 2. That's it. We have done with your main 2 tasks. Now what you are going to do? You are going to divide this by this. So you will get fs by n equals to mv square by r divided by mg. So m and m will going to be cancelled. So v square by rg. So this will be your 3rd equation. Okay. Now thing is, now frictional force depend upon the road. So you know that frictional force is directly proportional to the normal, correct? So that normal is nothing but when you are going to replace proportionality sign by some constant, you will get mu s. Here mu s is nothing but coefficient of friction, which depend upon the material. And we have done in 11th standard a practical inclined plane. If I am going to put an object on this, for example like this, so it will be as it is. When I am going to increase this height, after some time it will going to be fall down, just because of that angle. That's why it is here n. That normal reaction of that object was changed. Okay, so you have, now you are going to focus on 3 and 4. So by watching this, you will get fs by n is equals to mu s. So you have one relation like this and one relation like this. So fs by n and fs by n. So right hand side you will get v square by rg from this equation, and right hand side you will get mu s. So v is nothing but mu s rg. So this is your relation. This is your maximum safety speed up to which vehicle can perform circular motion. You can see that it depends upon coefficient of friction, radius of the circular path, and g, acceleration due to gravity. That's it. So here within 5 minutes we have considered this part. Now further after that we have considered in cylindrical. As a second part we considered wall of death or well of death. So again we had a cylindrical shape. In that vehicle was performing circular motion. This was center. So again weight of a vehicle acting vertically downward, normal reaction. Now in this case normal reaction will be not like this, because it is nothing but force exerted by the surface on the object. So here it is surface and object is here, so the normal reaction will be like this. So this was your normal reaction. That depend upon the condition that if the velocity will be minimum, friction will be not able to hold this weight of the object. So that's why that velocity should be that much enough so it can hold the friction, it can hold the weight of the object. That's why for maximum enough velocity your friction will be in this direction, correct? So we have done with what? All the forces acting on this object. Now here your first task, you have to write down the force balancing the weight. So here nothing but, now n will going to be height, and vertical force you are going to write, which is going to be give weight balancing condition. So here it is nothing but mg. Okay, fs is equals to mg. So here friction will going to hold the object. If velocity will be minimum, it will not able to hold, correct? So this was your equation number 1. Now second condition for centripetal force. So centripetal force will be horizontal force, which will give you normal reaction. So here horizontal force is nothing but which will give you what? Circular motion. So here horizontal force is only normal reaction. So that's why frictional force that equals to normal, which is nothing but mv square by r. So this will become equation number 2. Again you have to divide, so fs by n will be equals to mg divided by mv square by r. So m and m will going to be cancelled, so fs by n will be equals to gr divided by v square. So this is nothing but mu s, as we have considered in earlier case, because fs is nothing but mu s into n, where mu s is coefficient of friction, of static friction. So from this equation you will get v square, or I will write for simplify, mu s is equals to gr by v square. So this will go this side, this will go this side. So v square will be equals to gr by mu s, or maximum speed. So that friction will be capable to hold object will be this one, that's it. Okay, so this was example for, this is formula for horizontal curve rod, this is formula for in well of death in cylinder when object going to perform circular motion. After that we have considered for banked rod. Okay, for bank rod. So bank rod was nothing but, this is your usual horizontal rod, and if this surface will going to be increased, so that will be like this. So object will be like this, correct? So again there will be mg acting vertically downward. Now here again a normal reaction is slanted by theta. So from this surface your object has moved to this surface, so normal will be perpendicular to surface, so it will be like this. So this is the main important topic. Here you have resolved the condition. So this is normal. So here things are not well resolved, because normal is now slanted by some theta. So what you have to do, you have to resolve this component into two components, horizontal and vertical. So this will be your horizontal and this will be your vertical. Now for those students it is difficult to find the value of this part, I'll take you small revision for that. So suppose this is n and this is vertical force and this is horizontal component. Okay, so this is theta, right? So now you want to find the value of this part. Suppose this will be x. So if I join this part, what you can consider? If I join this part, what you will get answer like, for example like this. Now for this theta, this will be what? X, because the angle is made from this to this. Okay, so from usually normal is like this. Okay, now that has been changed to this, means this much theta has been changed. So that's why your x will be this. Now you want to find the value of this. So for this theta, this x is as a adjacent. So in which trigonometric function adjacent term comes? In cos theta. So for that cos theta is nothing but, so cos theta is nothing but adjacent upon hypotenuse. So here adjacent is what? X divided by hypotenuse is what? This whole term is nothing but n. So your x will be what? N cos theta. So that's why you are getting this as a n cos theta. Okay, and the similar term like this, it will become then n sin theta. So main aim is like this, from which side it is going to be make angle, that you have to know. So that's why here this part will become n cos theta and this will become n sin theta. Okay, up to this we have done. So before going to move toward the conditions for velocity, whether velocity is minimum or maximum, we developed a formula, and that formula was your main task: find the weight balancing forces, find the centripetal force providing forces. So your first weight balancing forces will be vertical. So here you will find what is that? n cos theta equals to mg. So this one will be equation number 1. And second, now centripetal force providing forces, so which is horizontal, okay, because it will follow this. So this will be given by only n sin theta. So it will be given by n sin theta equals to mv square by r. Now divide these two equations, so you will get n sin theta divided by n cos theta equals to mv square by r divided by mg. So you will here get v square by rg, and n will going to be cancelled. So tan theta is equals to rg. So this was your ideal equation. So depend upon the two conditions. So from v square, from v you will get rg tan theta. So this will give you maximum safety speed, so object will neither would fall down or move away from the object. And after that, from theta, tan inverse of v square by rg. So from these two equations, theta means up to what angle your rod should be there. Most of time it is at a minimum angle. So in these two cases, centripetal force was provided by normal reaction, and in earlier case centripetal force was provided by frictional force. That's it. This is the main difference. So depend upon the velocity, whether velocity is less than to this and greater than to this, we have studied the examples. So now we will move toward our next topic, which is nothing but conical pendulum, which we have already studied in previous class, in previous standard, but still you have to study because you are studying circular motion, and this is very important part of your that chapter. So the thing is, first of all we have to understand what is meant by conical pendulum. But before going to understand conical pendulum, we must know what is meant by pendulum. So pendulum is nothing but a tiny mass, or you may say it as a point object connected to a long flexible, massless, inextensible string and suspended to the rigid support. So this will be rigid support, and this will be long, inextensible, massless string, and this will be point object. So this type of structure is known as pendulum. Okay. So if string is made to oscillate in a single vertical plane, we call it as a simple pendulum. As you know that if this is the pendulum, if it is moving like this, so this type of pendulum is known as simple pendulum. Okay. That is, if string is made to oscillate in a single vertical plane, we call it a simple pendulum, like a giant wheel performing vertical circular motion. Okay. Now we can also revolve a string in such a way that the string move in horizontal. For example, now if for this is vertical, okay, now if I am moving like this, so it will be horizontal. So string move the surface of the right circular cone vertical axis. The point object perform a practically uniform horizontal circular motion. You will get clear idea by watching this short video. From video we have understood when pendulum will going to perform horizontal circular motion, that type of pendulum is known as conical pendulum. Okay. So we will solve mathematical expression for that. Now consider a bob of mass m. So suppose this is the bob of mass m revolving along a horizontal circle. Okay? So we have to consider this bob as a pendulum. This will be rigid support. This bob will going to perform horizontal circles, so after some time it will move to this part. So suppose that bob is at this position, so the string will be like this, and this will perform horizontal circular motion. Okay, so this is the structure of bob, where small m will be mass of bob, r will be radius of circular motion or circular path. Next, v will be velocity by which that object is moving. Now here, up to last year you have studied in terms of v. Now in this year we are going to study in terms of omega, because omega is nothing but angular velocity. So here omega will be angular velocity. Because it is easy to calculate angular velocity rather than v. So let's labelize this structure. So suppose this will be C, this point, support point will be A, and this point will be B. In given position B, we are going to find all the forces acting on this point object. So first of all, weight mg of a bob is acting vertically downward. Tension T naught in a string directed along the string toward the point A. Okay, so toward the point A. So this is the forces acting on a bob. Now here it is performing circular motion. So as T is a resultant tension in the string, so you can see that T is slanted. So what we are going to do? We are going to resolve tension. So how we can resolve this? This will be vertical component of T naught, and this will be horizontal component of T naught. Okay. So horizontal component will be given by, this one will be adjacent, so cos theta as we have studied earlier, so this will become T cos theta, T naught cos theta, and this will become then T naught sin theta. So T cos theta is vertically upward and T sin theta is horizontally directed toward the center of the circle. So as I said, we have done with all the forces acting on the object. So your task is to find forces acting vertically and forces acting horizontally to form equation of motion. Okay, so let's find the vertical acting forces. So here vertical force will balance what? Vertical force will balance mg. So what I said, that the vertical component T naught cos theta balances the weight. That's why T naught cos theta equals to mg. So this one will be your equation number 1. Your second task, you have to find the centripetal force providing force. So here centripetal force providing force is what? This force. What is that? T naught sin theta. That's why the horizontal component the horizontal component T naught cos theta then becomes the resultant force, which is centripetal. So you will get T naught sin theta equals to centripetal force given by mv square by r. So as I said that in terms of v, we have already studied in 11th standard, so we will consider in terms of angular velocity. What is that? mr omega square. So this will be equation number 2nd. So what we did, after finding the vertical and horizontal component, we have divided equation. So you are going to divide equation number 2nd by 1st. So you will get T naught sin theta divided by T naught cos theta equals to mr omega square from this divided by mg divided by mg. So T naught will going to be cancelled and m will going to be cancelled. So you will get sin theta divided by cos theta equals to r omega square by g, or you may simply write tan theta equals to r omega square by g, but according to your syllabus you have to write in this way. So g will go this side, r will go this side. So angular velocity will be given by omega square will be given by g sin theta divided by r cos theta. So omega will be equals to g sin theta divided by r cos theta. So back to your diagram. Now this is nothing but string. So this will be length of the string will be L. Okay. So this L is directed like this. So you can again make it simplify in a such a way that this will be theta. So this will become L cos theta and this will become L sin theta. I hope now I don't need to explain why here term L cos theta and here is term L sin theta. So this is nothing but r, radius of circular motion. So your r will be L sin theta. When you are going to substitute in above equation, you will get omega equals to g sin theta, r is equals to L sin theta and cos theta. So sin theta and sin theta will going to be cancelled. So you will get g by L cos theta. And as you know, angular velocity is nothing but 2 pi by t, number of oscillation performed per time. 2 pi is nothing but 360 degree, which is nothing but circle. Okay, so you can compare this. So you will get 2 pi by t equals to under root g by L cos theta. So if we reverse this, so you will get t by 2 pi equals to under root g by L cos theta. 2 pi will go this side, so you will get t equals to 2 pi g by L cos theta. So this is equation of period of a conical pendulum, that within the time t how much oscillation that object will going to perform, how much circular motion that object will going to perform. So this is nothing but period of conical pendulum. So this is most important point of this topic. After that, as you have period, so you have frequency also, that within that time that how much circular motion will going to be performed, t, that from this point after coming to this point again how much time that object is taking. So here frequency is nothing but 1 by t. What does it mean? You have to substitute this part, so you will get 1 by 2 pi L cos theta divided by g. So this is frequency. Okay, so this is nothing but conical pendulum. Thus, period of conical pendulum is the same as that of simple pendulum of a length L, where L is a length of the pendulum, or of a height h, where h is the axial height of the cone. The period of conical pendulum depends upon length of the pendulum, acceleration due to gravity at a given place, independent of mass as there is no any mass factor in this formula, and independent of theta because theta is small. Just because of theta is small, it is independent of theta. The principle of conical pendulum is used in construction of centrifugal governor, which is used for regulating automatically speed of engines. Let's study another application, that is vertical circular motion. So vertical circular motion will be like this. So if this is the object, it will going to form like this. It will going to perform circular motion like this. This type of oscillation is nothing but vertical circular motion. So it depends. There are two types of vertical circular motion. First one, not totally controlled by gravity, and second one, controlled by only gravity. In this case, initially supply the necessary energy at lowest point. Then onward, the entire kinetic is governed by the gravitational force. During the motion, there is interconversion of kinetic energy and gravitational potential energy. Let's study point mass object undergoing vertical circular motion under gravity. So let's study first condition, that is case 1, mass tied to a string. Okay, so mass tied to a string, suppose like this, it will going to perform vertical circular motion in this path. So we are going to find at different points. Okay, let's move. Consider a body of mass m tied to a string which is fixed at one end. Okay, so this string, that body attached to the string will be inextensible and reeled in vertical circular motion, not horizontal but vertical circular. It will be not uniform. Therefore, speed of the body is different at different points, just because of it is not uniform. Now what does it actually mean? As body moves, this will be lowest point. So as body move from lowest to highest, so this point will be highest. So as body move from lowest to highest, the speed of the body goes on decreasing because gravity opposes the motion of the body, and when moved from highest to lowest, the speed of the body moves from highest to lowest, obviously will going to be increased because of now gravity will going to be help. Hence the speed of body is minimum at a higher point and speed is maximum at the lowest point. Okay, so in which linear velocity is always tangent. Okay, at this point linear velocity will be tangent, at this point linear velocity will be tangent. Suppose this point is B, this point is A, this point is C, and this point is D. So at D it will be tangent. Suppose that linear velocity will be VD. Suppose here linear velocity will be VE. Similarly for this VA. So linear velocity will be tangential to circular path at every instant. So here I am only considering this 4 main point. So but at every instant it will be it is not visible, I think. Okay, so at every instant it will be tangential. In short, when body is in horizontal circular motion, weight of the body is perpendicular to centripetal force. In case of horizontal circular motion, weight of the body is perpendicular to the centripetal force. That's why it is constant. This motion of the body is uniform. But when body is in vertical circular motion, weight of the body is parallel to centrifugal force. Thus, resultant force is sum of weight mg and centrifugal force. The resultant force is sum of weight of object and centrifugal force. Thus, motion of a body is in non-uniform circular motion. For example, roller coaster, car slows down and speed up as it moves around the vertical loop. So let's form equation at a different points. So let's first we will solve for uppermost position. So both weight of the mg, so here this will be bob, from this point it will move in this, so as we are considering uppermost position, so bob, weight of the board will going to be act vertically downward, and tension in the string, tension process in the string is toward the center, so this will be also like this. So here we are considering different points, so we will name it tension at a TA. So it will give you information about the tension in the string at a point A, which is nothing but uppermost position. So both weight mg and tension TA are downward, that is toward the center. Now let's VA will be linear velocity of object performing circular motion. So this will be VA, performing circular motion at highest point. So centripetal force acting on object at a point A. So now you can see that this is in downward direction, provided by partly mg and partly TA. Then centripetal force acting on an object at a point A, partly provided by weight mg and partly provided by tension in the string. So that's why your equation will become mv square divided by r equals to mg plus TA, mg plus TA. Okay, so tension will be given by, then mg will go this side, mv square divided by r minus mg. So this will equation 1. So for minimum possible speed, at this point, that is at point A, tension should be 0. So mv square by r is equals to mg. So you will get v equals to under root rg. So this will be your minimum possible speed at a point A when string possesses tension. Similarly, at the lowest point B, the force on a particle R, so for B it will be, a string will be like this and bob will be at this position. So tension TB acting vertically upward toward the center, and weight mg acting vertically downward in the direction of center of the earth. So from this equation you can consider, now you will find here that mg and tb both having opposite direction. So that's why now as we are considering in terms of tension, so what we can do, it is toward the center, so tb minus minus sign because mg is opposite. So mg equals to, providing centripetal force, mv square by r. So here linear velocity will be vb, linear velocity at a lowest position. So from this, Tb will be given by m Vb square divided by r plus mg. So this will be your second equation. This was your first equation for a tension at a highest position. This will be second equation, tension at the lowest position. While coming down from the uppermost to the lowermost point, the vertical displacement is 2r. Okay, we are not saying that distance will be this part. I am saying vertical displacement, so that will be 2r, because from this point to the center it will be r, which is radius of the circular motion, and this will be r, so r plus r will be 2r. So displacement will be 2r, and the motion is governed by only gravity. Hence corresponding decrease in the gravitational potential energy is converted into kinetic energy. By using the law of conservation of energy at lowest point and highest point, its total energy remains constant. The mechanical energy, that is total energy in terms of kinetic and potential energy. The decrease in potential energy between the top position A and bottom position B. So by the conservation of energy, it will be given by total energy at point B equals to total energy at point A. In terms of kinetic energy and potential energy, it will be given by kinetic energy at B plus potential energy at B will be equals to kinetic energy at A plus potential energy at A. So kinetic energy is nothing but half mv square. So kinetic energy at B will be given by half mvb square, plus potential energy is nothing but mgh. So h at B equals to kinetic energy for uppermost position will be given by half mv a square, and potential energy will be given by mgh at A. Now here, B at B, h is equals to 0. A, and at point A, h A will be equals to 2r. So at B, hb is 0, and at A, ha is equals to 2r. When you are going to substitute in this case, you will get half m vb square plus h 0. So after multiplying 0, you will get 0 equals to half m va square plus mg 2r. So when this one will goes to this side, so you will get 2 mgr equals to half m vb square minus half m va square. Further we will simplify, so 2 mgr, we will take half m common, so half m vb square minus va square. So m and m will going to be cancelled, and 2 will go this side, so you will get 4gr equals to vb square minus va square. So you want to find value of vb, which is nothing but linear velocity at the lowest position. So vb square will be equals to va will going to this side, so va square plus 2gr. So from this equation you have va is equals to under root gr. So when you are going to substitute in this case, you will get under root gr plus 4gr as va is equals to under root gr. So you will get vb square is equals to gr plus 4gr, which is equals to 5gr. What does it mean? That Pb equals to under root 5gr. So velocity Vb at this position under root 5gr. So this is equation gives required minimum velocity at lowest point so that it can safely travel along vertical circle of radius r. So if velocity is less than this, then the string will be slanted. What is meant by slanted? Within the string there will be no tension. So at the same point, body will not able to reach the top point to complete vertical circular motion. Okay, so this is, and at this point it was under root gr. So this both the things are minimum velocity so that it can perform vertical circular motion. So now we will find velocities at point this C and D. So while drawing, you have to keep one thing in mind, that at this position, that's due to gravity, string will be under tension. So suppose this will be this distance from bob, it will be tension if you are showing like this. So when it will be at uppermost position, tension will be minimum. So when you are going to show TA, this distance should be less as compared to this distance. At C and D both are at a midpoint, so it will not affect that much whether you are going to find D or C. Okay, so you can show the same TC and TD, the same length as compared to this. So force due to tension is only the force toward the center, as the weight mg is perpendicular to the tension. So this force due to tension is centripetal force used to change direction of the velocity. So here direction will be along this, here direction will be like this, so this will be VD, and in this case it will be again VC. So the force due to the tension is centripetal force used to change the direction of the velocity, and weight mg is used only to change speed. Now using mathematics it can be solved. In book they have not given proper expression. Okay, so using conservation of energy at point C, you can find linear velocity. So by conservation of energy at point C, it will be given by total energy at C and total energy. Either you can choose lowest point or highest point. Suppose I am choosing highest point. So it is nothing but kinetic energy at C plus potential energy at C equals to kinetic energy at A plus potential energy at A. So it will be half m Vc square plus mg h at C, half m Va square plus mg h A. So you know that HA is nothing but 2r. So at C, height will be nothing but r. So here at C, h is equals to r. So that's why HC will be r. So when you are going to substitute, you will get half m Vc square plus mg r plus half m Va square plus mg 2r. So you will get half m Vc square plus mg r, sorry here I am like, equals to half m Va square plus 2 mg r. So 2 mgr will come this side, sorry, mgr will come to this side and this will come to this side. So you will get half m Vc square minus half m Va square equals to 2 mgr minus mgr. So you will get half m vc square minus va square equals to mg r. M and m will going to be cancelled, so vc square minus va square is nothing but 2gr. So vc square will be equals to 2gr plus va square. As you know that va is nothing but under root gr, so vc square will be equals to 2gr plus gr, which is nothing but 3gr. So vc will be under root 3gr. If velocity at midpoint will be less than this, again string will be slackened. Okay, so this is minimum velocity should require at lowest point. And similarly, this is velocity required at a midpoint, and this is also equals to Vd. So you got Vc equals to root 3gr. So you can compare that at the lowest point it is root 5gr, at the highest point it is root 3gr, at a midpoint it is root 3gr, and at the highest point it is root gr. Study some special cases, that is difference between tension at the lowest, which is nothing but Tb, and at the highest, which is nothing but Ta point. So at lowest means point B, tension is given by Tb is equals to m Vb square divided by r plus mg, and at highest point A, Ta is given by m Va square by r minus mg. So when you are going to subtract Tb minus Ta, so Tb is this one, so m Vb square by r plus mg minus this part, so this will become minus m Va square by r, and minus plus mg. So Tb minus Ta, so m by r and m by r you can take common, so m by r and under root in bracket Vb square minus Va square, mg plus 2 mg. So this has not proven in your textbooks, so write this in your notebook. So you will get Tb minus Ta is equals to this relation. So by the law of conservation of energy, that is total energy at B will be equals to total energy at A. What does that mean? That is kinetic energy at B plus potential energy at B equals to kinetic energy at A plus potential energy at A, which is nothing but half m Vb square plus mgHb half m Va square plus mgH A. So this is nothing but half m Vb square, which this part we have already done in previous derivation, plus h at B is 0, so this part will become 0, so half m Va square plus Ha is nothing but 2r, so mg 2r. So on subtracting this to this, you will get half m Vb square minus half m Va square, you can take common, that is half m Vb square minus Va square will be equals to 2mgr. Okay, so from this equation you will get Vb square minus Va square is equals to 2mgr. Okay, into this 2 will go to this side, so into what? 2 by m. So m and m will going to be cancelled. So this will become 4GR. So this you have to use in this. Make it as equation 1 or 2 in this. So what you will get? TB minus TA m by r in bracket 4GR plus 2mg. So TB minus TA equals to, so here r and r will going to be cancelled, so it will become 4mg plus 2mg, which is nothing but 6mg. So difference between tension at a lowest point and tension at a highest point, it will be given by 6mg. Similarly, tension at a C minus tension at A, because as we know tension at a C will be equal to tension at a D. When you are going to subtract from both TA, tension at a uppermost position, so you will get this kind of relation, okay, which is equals to 3mg. This thing you have to prove. Force due to the tension and weight are neither along the same line nor perpendicular. Tangential component of weight is used to change the speed. It decreases the speed while going up and increase it while coming down. So this thing we have studied up to this. So this kind of vertical motion will going to be performed while moving uppermost, speed will going to be decreased just because of gravity will going to be opposed, and when coming down gravity will help and there will be increase in speed. So we have found tension at a different points, linear velocity at a different point. So in this process there will be retardation, and in this process there is a acceleration. At every instant you can find the tension and the velocity. Let's study second case, mass tied to rod. So consider a box tied to rod. So instead of string, here we are going to consider rod and reel along a vertical circle, means we are going to rotate along vertical circle. So basic difference between the rod and the string is that string needs some tension at all the points, including uppermost or lowermost. Thus a certain minimum speed at highest point is not required in case of rod. In case of string we require this minimum velocity, so there will be tension in the string, but in case of rod we don't need this. So that's why in such a cases zero speed is possible at uppermost position. So while performing that vertical motion at topmost position, when there is a rod instead of string, we required zero speed. So we will use that mathematical expression which we did in earlier case. So I will directly consider this equation. So as for a rod, that VA is 0, so VB square will be equals to 0 plus 4GR. So VB will become under root 4GR, which is nothing but 2 root GR. So this is minimum speed at lowest position at a rod horizontal position. Okay. While that of difference between the tension at lowest point and the tension of uppermost point will be 6 mg. Let's study further application of circular motion when vehicle on convex over bridge, or this kind of examples may exist in terms of heels dump. When vehicle on heels, it will follow some this kind of shape. So this mathematical expression will be useful at that point. So the figure shows vehicle at the top of the convex overbridge. Now during the motion, forces acting on vehicle will be mg vertically downward, and normal, that force exerted by surface on the object, will be like this, that is n. Both are vertical lines. The resultant of these two must provide necessary centripetal force, as we did in vertical circular motion. So the resultant of these two forces will give you centripetal force, which is vertically downward. If the vehicle at uppermost position, okay, so that if v be the speed at uppermost point, so the resultant force will be given by mg, then n is opposite, that's why n equals to mv square by r. So this resultant force will give you centripetal force. As speed is increased, now here speed is increased, n goes on decrease, that is normal reaction will goes on decrease. For example, if speed increases, your normal reaction may be like this. So this normal reaction means force exerted by the surface will going to be decreased. So that can be formed at this position also, or suppose at this position your normal reaction will be maximum, while when you are going to downward direction, normal reaction will be minimum. So normal reaction is an indication of contact. Thus, for just maintaining the contact, n is equals to 0. This imposes an upper limit on the speed. So as maximum speed is nothing but under root rg, just because of your n become 0. So m and n will going to be cancelled, so r will go to this side, so v square will be gr, so v max will be under root gr. Our next term is, and last application of vertical circular motion, is sphere of death. So this is the popular show in a circus. During this, two-wheeler rider undergoes rounds inside the hollow sphere. Let's watch that video. Starting with the small horizontal circle, they eventually perform revolution along the vertical circle. The dynamics of this vertical circular motion is same as that of the point mass tied to the string, except that the force due to the tension T is replaced by normal reaction. So let's find that mathematical expression. So suppose this is upper surface of your spherical, okay, so here that rider will comes to this position. So at this case, now tension is replaced by normal because there is no string attached to this object. So in this time the mg will be vertically downward as usual, but normal is also at this because the surface exerting some force. Okay, that is nothing but normal reaction. Now thing is, your mathematical expression will be given by the centripetal force will be provided in this direction will be nothing but mv square by r will be equals to, now this time both mg and normal reaction are in same direction, so it will be given by mg plus normal. So as the speed increases, normal reaction will decreases. So suppose at a particular speed, maximum speed n is equals to 0, so your this equation will become mv square by r equals to mg. So which will give you v is equals to under root gr. So this is minimum speed, so that rider can perform in that sphere of the death. If the speed will be maximum, it doesn't matter, but it should not be less than this, or else that rider will fall down. Okay, so here we have ended with first half part of rotational dynamics, which is nothing but circular motion. Now from next lecture we are going to start rotational dynamics, that is rotational motion, and after that we will solve few numericals based on the topic taught within this lecture, and after that we will solve few repeated question of JEE and NET.